Imagine a computer that learns to recognize faces, predicts stock prices, even generates art or writes poetry. How? Through a concept inspired by your own brain. It's called a neural network. Let's uncover how this digital brain works and why it's at the core of modern artificial intelligence. What are neural networks? A neural network is a system of algorithms that attempts to recognize relationships in a set of data, using a process that mimics the way the human brain operates. But let's make that even simpler. Think of it like this. Your brain has billions of neurons connected together. Each time you learn something new, neurons fire and connect, forming memories, skills, and decisions. Similarly, in AI, we build digital neurons, nodes, and connect them in layers. These layers help machines learn from data and make decisions. Structure of a neural network. A neural network usually has three main types of layers. Input layer, where data enters. Hidden layers, where computation happens. Output layer, where final predictions or decisions are made. Each neuron in one layer is connected to neurons in the next layer, just like brain synapses. And every connection has a weight, like a dial that adjusts importance. The machine learns by adjusting these weights based on correct or incorrect outputs. Activation functions. The neurons spark. But here's the twist. Not every neuron fires at every moment. We use something called an activation function to decide whether a neuron should be activated or not. Some common types include sigmoid, relu, rectified linear unit. Tant. These functions introduce nonlinearity, which allows neural networks to solve complex problems, like voice recognition, image classification, or language translation. Without activation functions, neural networks would be as useful as a straight line, predictable and limited. Analogy: neural networks versus human brain. Let's break it down with a real-world analogy. Imagine you're learning to recognize dogs. You see many images: poodles, Labradors, huskys. Your brain analyzes shape, color, tail, ears, and stores a dog pattern. Next time you see a new dog, your brain says, "Yep, that's a dog." Neural networks do the same thing. They break input into features, assign weights, adjust through trial and error, and eventually make correct predictions. How neural networks learn. Training with data. Learning happens in epochs, repeated passes over the data. Every time the network makes a prediction, it compares it with the actual result. If correct, reinforce the weights. If wrong, adjust weights to reduce the error. This is called backpropagation, a core part of how networks learn. And the algorithm that manages these adjustments? It's usually gradient descent. It's like fine-tuning a musical instrument until it plays the perfect note. Real-world applications of neural networks. Neural networks are the backbone of many technologies we use daily. Facial recognition on phones, voice assistants like Alexa and Siri, self-driving cars, identifying road signs, medical diagnostics that detect cancer in images, fraud detection in banking systems, text-to-image generation, midjourney, doll. Writers like ChatGPT neural networks are not just theoretical. They're powering the present and shaping the future. Deep neural networks, DNNs. When neural networks become larger, with many hidden layers, they are called deep neural networks. Hence the term deep learning. These deep networks can learn extremely complex patterns like translating languages in real time, generating human-like text, reconstructing 3D environments, predicting protein structures, alphafold. But deeper networks also need more data, more processing power, better regularization techniques to avoid overfitting. Deep neural networks are powerful, but they need more attention to train correctly. Strengths and weaknesses. Strengths. Can solve highly complex problems. Learn from data without hard-coding rules. Adapt over time. Weaknesses. Require large data sets. Need lots of computing power. Often act as a black box. Hard to explain how they work. That's why explainable AI XAI is becoming an important field today. Future of neural networks. Neural networks are evolving rapidly with transformer models like GPT, used in ChatGPT, neural radiance fields, NeurFs, in 3D environments, neuromorphic computing, mimicking the brain's electrical behavior in hardware quantum neural networks. Still experimental, but promising. The future is not just more neural networks, but smarter, faster, and more efficient ones. Now that you understand how neural networks function like the brain of AI, in the next module, we'll explore deep learning and see how it powers everything from self-driving cars to AI-generated art. If this blew your mind, imagine what's next. Like this video, subscribe to the channel, Future Mind AI Trends, and comment. Would you trust an AI brain with your decisions? Let's keep learning, together.